Hi, everyone. Welcome to the Art of the Possible series. I'm Nihalini Yogi, and I am a principal cloud solution architect at Microsoft. Today's topic is a security in AI Foundry Agent, the developer perspective. With me, I have two of my amazing colleagues, Walter and Gabe. Walter, Gabe, I've truly enjoyed working with both of you, and thank you for your collaboration and being always available to bounce off ideas. With that, I'll let Walter, you guys, and Gabe introduce yourself. And over to you, Walter.
Thank you, Nehali, and welcome everyone. I'm Walter Novoa. I am a partner solutions architect for Microsoft Americas. My specialization is in some app innovation and also generative AI. Uh, so I help our partners to move or create their solutions on our cloud and using our services. And I am very glad to be here with you guys talking a little bit about agents in our Azure cloud. Gabe,
Th- Thanks, Walter. And I'm Gabe. I am an escalation engineer with the Azure AI um, CSS team. So I work mainly with products such as Azure Machine Learning, Azure AI Foundry. Um, Thank you.
Thank you, Gabe and Walter. So, we envision this series to be a multi-part series, and the goal of the first session was to show the network plumbing and perspective with a mock scenario, and today Walter will be showing us a more realistic scenario with a developer perspective. Walter has also built a fantastic workshop for developers to learn, and we will share the GitHub repo link below. The founding principles of these sessions are to inspire collaboration between the infrastructure teams and dev teams and to grow and learn together. And we will be doing a lot of real-time troubleshooting. So if something breaks, we'll fix it together. With that, Walter, take it away.
awesome. Thank you, Nehali. So yeah, this is the session where we'll dive deep into the development of intelligent agents with a multi-agent architecture using um, uh, or from a developer's perspective, no? So um, in this session, we will embrace a pro-code approach that gives us full control over how these agents are created, configured, and executed entirely through code. So this empowers us to build truly customized applications tailored to complex real-world needs. But beyond functionality, we'll also address a critical aspect often overlooked in the demos that we could find around, and it is network and security. So we will also be exploring how to optimize our solution so it can operate securely within both public and private environments, aligning with the security and compliance expectations of our enterprise customers. Okay, well, in this diagram, we can see our Azure AI Foundry, a platform purpose built for developers to create intelligent generative applications with structure, scale, and security in mind. At its core, AI Foundry combines powerful services like our Azure AI agent service. It also ships models like the ones in Azure OpenAI services and uh, our big model catalog with more than 10,000 models available for us. And um, we also offer advanced tools such as Azure AI Search that enable us to compose intelligent workflows through agents that reason, that can call tools and interact with other services. And this is not just about the models, it's also about the orchestrating capabilities that our AI Foundry can give us. And uh, also, we offer this observability layer that help us with the governance, and we also have customization tools that allow us to move confidently from experimentation to production. And as part of this session, we'll also briefly touch on network configuration because deploying these solutions in secure real-world environments often mean aligning with enterprise networking standards like private endpoints and access controls. The centerpiece of this experience will be, again, our Azure AI Agent service. And this is the engine that enable us, pro code developers, um, to build, manage, and run these agents. So with that foundation in mind, we're ready to deep into our next key concept. What exactly is an agent? In Azure AI Foundry, an agent is much more than just a prompt. It is a modular, intelligent entity capable of reasoning, acting, and interacting with the world around it. To understand how agents work, it's useful to break down into four core components. The first one will be its personality, and this is what we also know as the system prompt or the meta prompt, or maybe the instructions, as we call uh, this in AI Foundry. And this is the foundational layer of the agent. It is defined by a system message or a set of instructions that shape the agent's role, its behavior, and also the tone. Think of it as the agent's personality. For example, the who I am that guide its responses and decisions. Then we have the intelligence, and this is where the language models are helping us. The reasoning capability of the agent is powered by one or more language models, such as GPT 3.5, GPT 4, DeepSeek, Rock, all of those different models that we are offering in our model catalog. And these models allow the agent to understand natural language, generate responses, and make decisions based on context. Um, so basically, this is where the agent thinks and help us with these reasoning capabilities. Then we have the tools. Uh, these tools are what allow an agent to go beyond the conversation and actually do things. They extend the agent's capabilities by enabling interaction with external services, systems, or data sources. Within this category, the tools category, we can distinguish two key types of tools. The first one is the knowledge tools. These are like the books or the knowledge that the agent um, has available for it, and can give the agent access to information beyond what was included in the original language model training. And these tools allow the agent to retrieve facts, create document indexes, access enterprise data, or tap into customer knowledge bases. And we also have the action tools. Those action tools empower the agent to perform operations such as calling APIs, triggering workflows, invoking Azure functions, or even interacting with other agents. And these are what turn the reasoning into results for our own objectives. So together, these components make up a complete agent, one that can reason, that can act and adapt. And throughout this session, we'll see how we can define and control each of these elements directly through code using our Azure AI Foundry. Well, I don't know if do you have any questions about what we have just seen before we move on, Nehali or Gab, about this?
Nothing so far. I love the representation. The PowerPoint slides kind of matches the portal experience as well. So I like it a lot.
Excellent. Thank you, Nehali. Well, so for our workshop, we will be working with this GitHub repo that you can find in the links of this session. And basically, we are going to work with an application that could take uh, an instruction or a prompt in natural language where the user asks to the application to generate an online business card for a given person. No? For example, in this case, it is as here um, the user is asking for a business card for Walter Novoa, who is a cloud solutions architect from Colombia, and then the agent will do the required analysis and actions to generate business cards like this, and then publish it on the web so it could be accessible in a public way. No? Um, this is an input in which the user gives everything that should be represented in the card, but taking advantage of the power of LLM-based agents, we could also ask a, a, a very simple prompt without too much data. For example, this one, a recently graduated marketing girl in Africa. And as you can see here, there is a lot of information that should be uh, inferred here or created by the agent. And that is what actually the agent does, and it will create the rest of the information required to generate a card like this. So you can see here that it created a name, it identified a city in Africa, as we instructed here, and then a profession based on the prompt that we gave, and a welcome message from this person in um, in its card. And how this have been created? Let's see a little bit more about the architecture of the application. We will be working with a Python console application, and it will be the one that would allow us to connect to agents in Azure, especially in our AI Foundry space. This is where our agents live, no? And as you can see here, we have two agents. One will be an orchestrator agent, and it will be in charge of receiving the prompts and analyzing what to do, and then distribute the work among the tools that are associated with that agent. So this is why this agent has this component here beside it. It is called tools. So we have two tools for this agent in this case. One tool is this Azure function, and the other tool is another agent, because we could have this many different tools that will help uh, an agent to create to execute its work. And one of those could also be another agent. No? And this is another the other agent that we will be using. It is called the JSON card generator. Basically, the function of this agent is very punctual, very basic. It takes a prompt and extracts information from it in JSON format. That JSON format is the one that will be sent to the Azure function. So the Azure function could download a template that will represent the business card and then fill the template with the JSON data that was extracted by this other agent. So we start with some natural language prompt here that prompt is converted into JSON, and then that JSON is sent to the function. It is replaced in the template, and when we already have a replaced document, we would publish it uh, in the Azure storage as a public blog, so anyone could access to it using just a browser. And we also have here for our agents, remember that we have um, another component that is the intelligence. So for the intelligence, these two agents will be accessing the GPT model. In this case, we will be using the 3.5 model because this is a very simple task that doesn't require too much intelligence to be executed. So we have chosen this simple and cheap model for you to explore also without incurring in higher costs. Um, but we could have here any of the thousands of models that we have in our model catalog. Okay, so everything related with agents, as you can see here, will be in our AI Foundry. The Azure function resides outside the AI Foundry, especially in a flex consumption plan within an app services. We have chosen here the flex consumption plan because it is the most basic configuration for functions that would allow us to have then um, private endpoints. No? So with these private endpoints, we will be able to secure all of this architecture within as a private network, and then give uh, this solution a, a very secure environment to be executed, for example, for production purposes, because nowadays enterprises are very interested in have all their artificial intelligence and in general all of their solutions within secure environments, especially through private networking processes. So Flex is a very good option to achieve this. And then we have our Azure storage that help us here to have the template, like the base for the cards, and then to uh, be the repository for the generated cards. And that is why we have two containers, two Azure Blob containers, one for the template and one for the generated cards. So yeah, I'm gonna pause here and see if Nehali have any comment or questions about we have seen. Please, Nehali.
Yeah, so Walter, this Python console app that you have in the bottom left corner, that would actually programmatically deploy the agents. Is that correct?
Yes, we have designed this in a way that if these agents are not present or are not created in the AI Foundry, we could use our agent service SDK to generate these agents through code. So you could automate everything here and don't have the need to get inside the AI Foundry and create the agents manually as we did in the last session. No?
Mm-hmm. Mm-hmm. Yeah.
Um, so this will give us the contrast of how to make the things with low code or no code approach, as we saw in the last session through the AI Foundry portal, and also how to do it with just code. No?
Got it. Yeah. And one more question. The app service, could you talk a little bit about the app service up at the top? I know we don't have it in the demo today, but just to kind of complete the full perspective, how does that work in a real scenario?
Yeah, actually, we do have it.
Oh, nice.
It is up and running in the public environment. So um, the app service is a service in Azure that allows us to deploy uh, HTTP services that will be consumed, for example, using REST clients, and also we could deploy them websites that could be seen in a browser. In this case, we are using it to run an Azure Function application that will be like a microservice that will serve as a tool for our agent to really execute things. No? And there are many uh, tiers of our app service that will give us different uh, capabilities. Um, and as I told you before, we choose the flex consumption mode here that allow us to have private networking while keeping the cost lower because it is also serverless. When we are not using the services within this kind of flex deployments, the unused instances will be shut down and then they won't generate costs. And we also can determine if we could let at least one instance run. So whenever a user needs to call the service, it will be ready to go. And if thousands of new users arrive, then there will be a scaling operation that will increase the number of instances. So it is, as its name implies, a very flexible kind of application service that we have for you in Azure.
Awesome. Thanks, Walter.
Yeah, uh, and as I told you before, um, this solution um, is created just to highlight this kind of interactions with our agents and how we can handle them with code. Everything that is required to run this, you can find it in this repo. And to start working with it, it is recommended that in your developer machine you have these tools here. Um, of course, Git and GitHub if you want to have access to this. And this is our creator for Python 3.12 and beyond. And we also need .NET because this Azure function that we saw before it is created with C sharp. You could also create it with Python, for example, but just to give more diversity in terms of programming languages here, I have choose to create that Azure function with .NET. And actually, this function that we have here inside Azure, that could be an external um, service running in other cloud or on premises if you want. So the tools for an agent, they don't necessarily are required to be within Azure in order to uh, work with AI Foundry agents. You can have any tool in any place, and you can just call it and make that tool available in the toolset of your own agents. So that is why we need the .NET SDK. And if you want to run your function locally without deploy it to Azure, you could also install the Azure Function Core tools. And of course, Visual Studio Code to work with the solution. Uh, these extensions are very recommended to make the work in Visual Studio Code easier for this workshop. So Python tools for Visual Studio Code, Azure Functions, C Sharp, and also a REST client is recommended. If you um, uh, don't have any REST client, we have recommended here this simple REST client that would integrate very good into your Visual Studio Code, or maybe you could use also Curl or Postman. That is up to you, but it's always good to have a very good REST client to test the APIs, and in this case, it will be used to test the Azure function that is part of our solution. Uh, I have created a script. It is in the repo that will install all of these things for you if you are on Windows, because in the end it uses Winget. So if you want to have this environment ready automatically, you could just run this script in your Windows machine. And after you have your environment ready, um, we need to set up all the services that are required in Azure for this to work. Um, we could do this manually or also using a template. In this case, I have created in the repo a folder called infra, and within it you could find a script that will deploy all of these things that you can see that are required for this workshop. For example, we need, of course, the resource group that will have all the elements required for this workshop. It is like a logical container for the things or the services that are required for this. And these services are a storage account, as you can, as you um, so before it has the containers, the template container and the business card container. We also are going to need an Azure Function app to act as a tool for our agents, and surely the Azure AI Foundry um, that will give us the intelligence and the agents to work with this. So it is an ARM template that it is in the repo. You could just run it and have this deployed into your subscription. Uh, but for now, I would like to show you how this look in Azure. So this is the resource group that I have chosen to be created for this. And these are the services that were deployed with the script. So we have here the AI Foundry instance that will help us with the agents and models. And then we have the Azure function with its app service plan. And this is our Azure storage account. So just these four elements will help us to start working on our solution. Mm, Once they are deployed, we can go ahead and start configuring because at the beginning we only have the services ready to work, but they need to be set up with some special things that we need for our worship. For example, we need to create um, a, or upload the, the template that is nothing more than just a simple HTML file. And that template it should be uploaded within the templates container in our Azure Storage account. For that, you could use the Azure Storage Explorer, or you could go ahead and run this command in your within the the repo folder. It's okay. So let's see how this looks in our Azure Storage account. Um, so get into the account from our resource group, and here in containers, you could see that both cards and templates containers were created by the script. So the file will be uploaded here inside the templates uh, container, and the generated cards that will be residing here in this container that it, it has a different configuration than this one because these were created using public access enabled. That is what allows us to access the created cards through a browser without any authentication, just like a normal web page. But the contents inside the templates, it will remain private. And then we have our Azure function at the beginning. It will be just the container of the code that we created. So we need to deploy that code to the Azure function. Um, there are many methods to make the deployment of the Azure function. We could use the console to deploy the function, or maybe the visual helps that we have in Visual Studio Code on Visual Studio, or we could also use the core tools to do this. So you could use the one you prefer to deploy your Azure function there. And that Azure function also is configured especially by the deployment script. So if you don't use the deployment script to create the function, then you should keep in mind that it is recommended that this function has an environment variable um, that that has the storage account connection string that will allow the Azure function to get connected to the Azure storage, download the template, um, fill it, and then publish the file in the blob storage. So it is required that the function has this environment variable set. It is called Azure Storage Connection String, and of course it has a the connection string of the storage account that we just saw in the previous step. Other than that, this is a very simple Azure function. So when I was creating it, I just choose 512 megabytes of memory for the instance. That is the lowest amount of RAM that will be given to a Azure function in the Plex consumption model. So we are keeping everything very frugal here in terms of consumption. Okay, and then there is our Azure AI Foundry. Uh, Again, just the container service for this was created. We need to create an AI Foundry project within the AI Foundry and associate this project with a deployment. So a deployment in AI Foundry, it refers to a model that had been made available for the agents to be used. So that is a deployment uh, for the ones that haven't worked with this before. So let's see um, how the AI Foundry looks for us. I'm gonna share it. And there's something special with the AI Foundry, and it is that you cannot directly see everything about the AI Foundry within the Azure portal. You need to go to the dedicated AI Foundry portal. That is why we have this button here. It opens a whole different portal from the Azure one, and we will end up with kind of an IDE for creating artificial intelligence applications. We have almost everything that we require here in this environment, this web environment, and um, at the beginning we won't have any project here to work with. A simple wizard will appear and ask us to create the project, just a name, and that will be enough for us. And having that project, we just need to go here to models and endpoints and create a new uh, a new deployment. We have here two deployments, one for GPT-3.5 Turbo. It is very cheap, but it will be retired soon. Look here, August 31. So after that date, it will be replaced with someone of the 4 family. Um, but yeah, for this case, it will be enough with this. I have this other one because the repo, it is evolving and we will have more advanced features such as a, a creation of reports automatically by reading a database and things like that. And so you could just follow the repo to see how it is evolving and how to deploy a model. It is very easy. We could deploy two kind of models: base models, the ones that come as they are from the um, providers, and then we could also deploy fine-tuned models. Those are models that we have customized for our requirements in terms of how the models will be answering to the prompts. So for this case, we will deploy in a base model. And you just have to look for the one that we will be working with. In this case, GPT 3.5 and confirm. And with that, it will be just deployed to your AI function. You for you to follow this workshop, you could leave everything in its default configuration. and you will end up with a deployment like this. Here, it is very important the name because it is the thing that will tell your agents which of the deployed models that we have in our AI Foundry will be the one used to solve the tasks that are assigned to them. You could also test these deployments in something that it is called here the playground, and uh, just get into the chat playground and choose the deployment you want to test, and just start chatting with that deployment. This same playground is also available for agents, as we saw in our last session. You just have to choose the agent you want to talk with, and it'll be available to try it in the playground, and you could start working with it. I'm gonna delete these two guys here uh, because, as I told you before, the code it will be able to detect if these agents are available or not. Actually, these two agents are the ones that make our solution. This is the main one, the orchestrator, like the most complex of those agents, and this is the one that just generates the JSON. You can see the instructions here. These instructions, I didn't wrote them. They were injected in the AI Foundry through code. Um, we could see that when we start exploring the code. But for now, let's delete the agents. Okay, and as we have everything prepared on Azure, we could clone the solution and start working with it. That solution has a very interesting structure. I would like to explain a bit about it for you. For example, we have the agent webmaster folder. You can see here that it says spy, and this is because here we have uh, all the code for the agents, and it was created using Python. But you could also create your agents using C Sharp, for example, or JavaScript too. We have versions of our agents SDK for these languages. Um, and here you can see that we have a .m file. It will have all the environment variables required to your agents to work. For example, um, what is the endpoint of your AI Foundry project? So that is like the address of your project. So your application could go there and start working with the agents that are living within that AI Foundry. It also has the storage account. Well, everything that is required, it is there. Uh, we also have the requirements, the packages that are required to for your application to work. Uh, and then we have the folder for the agents. This is the basic agent, the car generator agent. Um, it has a main logic here, and then it has a tester application that we could use to see that this is working well. So this agent, it only receives a natural language prompt and returns a JSON. It doesn't create any card, just returns a JSON. This is another agent, an advanced agent that we are not covering today. This is the report builder. I mentioned it before. And then we have the WebGen, that it is the main agent. And as you can see here, it has the main logic and also a tester. And it also has a folder called tools. And these tools contain all the information required for this agent to understand that it has a natural function available for it, for example. So this is why we have uh, this folder here. This other agent, the first one, as it is very basic, I have not created a tools folder here because it is not using tools actually here. Just it's a pure content generator agent without having to use any tool, just the knowledge it has from its initial training. And then we have this other folder. It is the folder for the Azure function. Uh, so as you can see here, it uses C Sharp and um, it has two main functions. One, it is called the template filler. As its name implies, it is the one filling the templates and then publishing to the storage. And this SQL query is another service that is for the advanced scenario in which an agent could take a natural language prompt, convert it to a SQL query that will be executed by this Azure function, and then will get the results, and another agent will convert those results into a beautiful report that could also be published in the web. And basically, these two folders are the ones that has the code for the application. Then we have the infra folder. If you remember, this is where you could find the infrastructure description in ARM format, uh, and the parameters that you could change for your solution to be unique. Because, for example, the Azure Storage account, it needs a unique name, so you just change it here, and when you have everything ready, you could deploy it using this PowerShell script, or you just can go into the Azure portal and run the ARM itself. All the instructions are in this README. It is a README made just for the infra deployment. And we also have this miscellaneous folder where you can have samples or some things. And you can see here the Windows um, environment script. It will download all the tools required for your development environment in Windows. But yeah, you could also have Visual Studio Code in Linux or Mac, and do your own environment in those other um, operating operating systems. And yeah, after this, we also have the requests folder. It has samples of how to test your Azure function using some posts. You could use Bruno, that is um, another REST client, and you can also use the REST client that was recommended before. And finally, we have a web app. It is also being developed to replace the console Python app to have something more like uh, deployable with more reach than a simple console application. And this also is a working process, but today will be enough just working with the console application. Um, okay, after that, in the repo, you could also find instructions on how to run the Azure function locally. You have to make some adjustments there, and the same for the Python application. Especially, you need to create a .m file because, as you know, these environment files they contain critical information that is not intended to be pushed to a GitHub repo because otherwise your secrets will be available to everyone accessing the GitHub repo. So this is why these kind of files they don't usually get uploaded. So for that reason, I provided a .m.txt file with a sample of how you would create the actual .m file. You just need to replace with your values and then remove the extension, and you will have the um, environment variables required for this. So with that, let's just step into our Visual Studio Code and see the repo already cloned. I don't know, guys, if you have any question or comment, Nehali, before we continue with this, or Gab.
Yeah,
Yes.
so uh, uh, one question I have, actually two. I just noted it down. So this infra folder that you showed us, Gabe, sorry, Walter, in your repo, the infra folder and the infrastructure components that got deployed, right now they are in public settings, right? From in Azure.
Yeah, that's right. The configuration that you can find here in the infra folder,
Hmm.
it is just um, created and focused to a public deployment. So nothing about virtual network here or private endpoints.
Yeah, so that we will do in the second half, right? Just wanted to make sure we call that out.
Yeah.
And then the second question I have was I really liked the script that you have prepared for an ideal development environment. So thank you for doing that. So where I missed that part, where is that script for setting up a good development machine? Because as an infra person, I often struggle with that one.
Yeah, thank you, Nehali, for noting that. Within the MISC folder here,
Uh-huh.
you would find the setup dev.mist.
Perfect. Okay.
It is a PowerShell, and as you can see here, it is using Winget, a powerful tool that we have in Windows to
Hmm.
install Visual Studio Code, Git, Python, .NET, and
Yeah.
yeah, here is it.
I think
Actually,
you and I have talked about having, for me to have a dream development machine someday. So this is a great start. I can't wait to
yeah,
try this out.
I had my own script for my environment. So whenever I get a new machine or have to format my machine, then I just run this and wait for some minutes and or do another thing. And when I came back, I have everything ready in and installed in my developer machine. So yeah, I could write uh, a script for this, like this, for you to have your own developer environment, Nihali.
Thank you. Thank you, Walter.
Yeah. Uh, I thought Gabe maybe. had a question?
Uh, yes. So are there any specific constraints or limitations that the specific resources need to follow? So, for example, does the storage account have specific permissions or settings that need to be set for this to work?
Yes, for example, um, in the case of the cards container that was created, it needs to be um, configured with public blob access. By fortune, the script do this for us. Um, Here you can see that we are creating the container,
Mhm.
and then the script change its configuration to make the block the container public for blobs.
Okay.
Uh, if you are not following the script, you could always do this also manually in the portal. For example, um, in the configuration, you can go to your um, settings. I'm
Mhm.
sorry, you could go to the cards container, and then you will be able to change its public access, it access to public, no? So
Okay, I see.
this is what we need to do for it to work.
Gotcha.
Other than that, Gabe, I think this solution is not very demanding in terms of configuration. I think
Mhm.
this is the only special thing that we need.
Okay. And are we using keys or identity to add the templates to these containers?
Yeah, for this to work, we are just using keys to
Hmm.
keep it basic.
Gotcha.
So if you need to get those keys to access your storage account, you just came here to access keys and just go to the connection string. You copy it and use it where you need it.
Gotcha.
Uh, Actually, this is what I showed you before,
Hmm.
that we configure it in our Azure function in the environment variables. That
Mm,
that value that I copied before, it is the one that is here.
gotcha.
Yeah,
Cool. Thanks, Walter.
a pleasure. So yeah, let's see. Let's start with the infra script. Um, as you can see here, it is JSON. This is what we know as an ARM template. Azure can read this and this code and, and convert it into infrastructure. This is why we know here this as infrastructure as a code. And we also have the parameters file. And this is the one you will be modifying. The resource group, if you want, you could leave it this way. The location, well, there are some locations that don't have um, the agent service available. So one of the valid regions is US 2. The storage account. This is very important that you uh, replace with something that you are pretty sure is unique, um, as well as the function name and the foundry name. This should be changed by you. And when you have everything ready in your console, in your terminal, you just get into the infra folder and Let's make this a little bit bigger. Yes. And once inside the infra folder, just call your script if you are in PowerShell, no? Because this is a script for PowerShell. You can just run it. If I hit enter here, it will start deploying these components again. And these are the instructions for you to be comfortable following the required steps to have your infra ready on Azure. Well, and so we have seen the MISC. It's like a folder with different things for us to use. These are the requests. So this is a request to test our Azure function locally. If you want to test deploy Azure function on Azure, you just change this address. Uh, but this is what the Azure function is expecting. A JSON with the information to be injected into the template. Um, and then it will publish the template in an Azure account when it is already filled. Uh, so this maybe we could uh, start working with the code of the agents to see how are they working. Um, as as I told you before, there is an agent folder with our agents. These are the two that we are working with today, and this is the advanced one. Let's start with the basic one, and it is the agents card generator. Um, we need actually two very important packages to work with agents on Azure. The first one is the uh, agents package, and the other is identity, because with identity we will be able to log in into our AI Foundry and start working with it. And the agents, it has all the logic to work with agents. All of those packages are described here in the requirements file. Um, this is a very common pattern that we have on Python with Python applications. We have a file with the requirements, and then we execute a command to install these packages using a tool that is called pip. Um, so when we run a pip install, it will look for all of these packages in the internet and install it locally for us to work with them. Um, and we have these package projects. It is the one that will allow us to work with AI Foundry. And then we have this package of agents to work with the agents inside AI Foundry. And identity, it is for the authentication purposes. And also we have the storage blob package for us to be able to work with Azure storage. And this one .env, it is not related to Azure. It is useful to be able to come here to the .env file and read the environment variables that we need for our application to work. So as you can see here, I have made available this .m.text file that will help you to have like a placeholder for your environment variables. You just need to change here the project endpoint of your AI Foundry and the connection string for your storage account. You need to change it as well as your Azure function URL. So let me show how to get those values. When you have them replaced in your real.m file, these are comments, I can get rid of them. Uh, as you can see here, now I have real values here. How to go to get those values? Let me go back to the portal. And for the Foundry, if you go to Overview, here you have the project endpoint. You just copy it and then paste it in your file. And here in project endpoint, you will paste that value. And the Azure Storage Connection string, you already saw how to get it. And the Azure function URL, uh, you just go to your Azure function. And here is the specific function we deployed. And yeah, here we have three different URLs for our function. I recommend to use this default function key because it is the one created for regular um, client applications to use. And we just copy it and pass it to our file here, our .m file, and paste it. There's something important here, and it is the code. This is the thing that allows us to authenticate against the Azure function. So as you can see, everything gets authenticated on Azure. So we can guarantee that we are having a secure deployment. And yeah, for our case, these are the only variables required. Don't mind about the SQL connection string yet, because this is for other scenarios. Um, let's test our Azure function. We could do that now that it is deployed on Azure. Um, we have this functionality here called test and run. We should choose this key that we just got and put here the body uh, for the post action that will be executing against our function. If you remember, we have the requests folder with sample of uh, works for the function. We just can copy this and launch it here and see how it runs. You see, the answer of the function is just the URL of the generated card. You can just copy, paste it in a browser, and we have there the generated card. So you can see that this is missing. We can uh, erase that. Observe that observe that this is the JSON and this was the function. The function is not smart enough to fill this automatically for us. So we need to guarantee that the generated JSON comes with all the required information. Um, so in the samples here, we have a complete sample. Actually, let me update this because it is better that we have the whole data here. And let's update that also in our Azure function and run it again. Grab the URL and watch it here. There you go. So now we know that our Azure function is working. We tested from the portal, but we also could test it um, using our um, our extension, our client REST client extension. It is already installed in this Visual Studio, and as you can see, I just need to hit send request, but it is pointing to localhost right now. Let's change the address for the one on Azure. It's this one. Let's make some changes here. For example, paste from VS Code. Uh, let's use another name. So this is journalist. And yes, let's skip the rest and send this request. But let's then follow this send request to see the response from our Azure function. Yeah, as you can see, this um, extension allows us to execute the request from our Visual Studio Code, and this is the answer from the function. So we could go here and see the generated tar with Peter Parker, who is a journalist. So everything is ready from the Azure function side. Um, let's go back to our card generator agent. Uh, as I told you before, the packages were already installed thanks to the requirements text. Um, and with that, the first thing that we need to do is create an object that is of type agents client. So this client will help us to communicate with the agents that we have in our AI Foundry. Um, to create it, we need to know what is the address of our AI Foundry. That is why we are getting that value from our environment. The variable is called project endpoint, exactly this one, project endpoint. No? And to read this, we need this operation load.m. It will read that file that we have there, or the environment variables that are in the system. This is why we need this package. So once we have the endpoint, we also need the credentials to access the service. We are using the default Azure credential in this case. And for this to work on our developer machine, we need to log in into the Azure subscription that contains the AI Foundry that we have deployed. To do that, uh, we installed the uh, Azure CLI tools for our console, and that will allow us to do things like this: Azure AC login, AC login use device code, and that will ask you to get into this website and put this code there. And it's recommended that you visit this address from the browser that you have logged in with your Azure subscription, so you could use the same account there. So let's open a new tab and visit that web page and put the code that the console gave us to us and choose the correct user to be logged in. Yeah, so it is ready. We could close this and go back to our Visual Studio code. You can see that after that, it detected the subscription that we have and choose the one that we want to activate. As it is just one, we just hit enter and it will be selected for us. And yeah, now we are logged in. We can confirm that using this command AC account show. And if it gave a JSON like this, it means that we are logged in. So as we are logged in, this line will work and we will be able to create our agents client to communicate with our AI Foundry. And this is the method that give us this agent client. It is like a transport, like a car that allow us to go to the AI Foundry and start communicating with it. And after that, we need to retrieve the agent if it already exists in AI Foundry, and if not, we need to create it. So first, we tell the client to list all the agents that it detects in the AI Foundry. And if in that list of agents, it finds someone that has the same name as the agent name we are looking for, that in this case is the agent car generator, it means that the agent already exists and return that agent. But if not, we need to create it as a new agent. And here are the instructions that I told you before. I injected from here to the AI Foundry using the code. But here I'm telling the agent how to behave. It will be a creative data generator for professional business cards. And when asked to generate a card data, it returns a JSON with these 6 fields: the title, name, city, profession, message, and date. And as you can see here, I detail very uh, thoroughly what we need. For example, a real city name from any country, the date, how should it be formatted, the message, everything. I also instruct the agent to be very creative and diverse, use different cultures, etc. And finally, I give it an example. So it will be very clear for the agent what we are needing here. We are going to need a JSON with this structure. And after we have defined the instructions for the agent, we ask the client that card that I told you we created before to create the agent. And if you remember, an agent has uh, four different components. This will be uh, the, the intelligence part of the agent. This is the model. This is an environment variable with the name of the model that we are going to use. That model should um, be in sync with the deployments that we made. If you remember, we made a deployment of the GPT 3.5 model. And if you go to your environment file, that is the name of the model deployment that we are going to use here. So uh, we have the intelligence part here. Then we have the name for our agent. It is car generator. Then we have this description. It is just for human uh, understanding of this. This is not used for by the system. It is just for us to identify what this agent is going to do. And then we have our instructions. So if you can see here, the only thing that is missing, it is the tools, the tool set for the agent. But if you remember, this will be a very basic agent, so we don't need to specify tools to create it. So when the agent gets created, uh, it, it will start running on Azure, um, waiting for us to call it. And then we have some uh, traditional code here to make this functionality available to other models, to other parts of our application. So this doesn't have to do with AI, but just a normal Python operation. Actually, this is what allow us to create this tester. It is just a console application. As you can see, we import the model we just created with the agent card generator. And this is the thing that we run to see our agent in action. So let's run it. This will be our prompt. We can make mistakes, the LLMs can understand everything. And this is the JSON. As you can see, it only gave us the JSON. It doesn't give us any card, just the JSON. This JSON will be taken by the orchestrator agent and then sent to the function for it to work. For now, we can see that our card generator agent is working and we are happy with that. So let's go to see the orchestrator agent, the complex one. Let's see the code. At the beginning, it will be very similar to what we have just seen with the basic agent. This is the uh, creation of the agent's client, the card that will help us to communicate with them, with a project endpoint, with our credential. Uh, and this is how we can see if the agent is created or not. Actually, this this give me an idea, and it is show you how is our AI Foundry now that we have run the agent card generator. Yeah, so let's go to our agents part. You remember we deleted both agents, but now the card generator was created. No? And it has the instruction that you saw that I injected from there in code, even with the form, the example, and everything. And for the model, you can see it is 3.5 turbo. And there are no tools. It is a simple agent. So after running our next agent, it would be created here. And if I hadn't this um, this control here, detecting that the agent already exists, whenever we run this program, it will create a new instance of the agent in our AI Foundry, and that is not what we want. So that is why I created this control part here. And here comes the different thing. We now have tools for this agent to be able to execute actions. And the first tool will be a connected agent tool. Uh, If we go to our AI Foundry, we have this section, connected agents. So we can add manually here a connected agent from the ones that we have in our environment. As this is the only agent, there is no other agents to attach to it. But I just wanted to let you know that we could add these connected agent tools also uh, visually without any code in our AI Foundry. But for our workshop, what we do is create a new connected agent tool. This object is in our package that we installed in the exactly the um, agents package. No, so this connected agent tool will require the ID of the agent that we want to attach to this one that we are creating. If we go to Azure AI Foundry, you can see that this card generator we created has a unique ID. So it is the one that identifies this agent in our AI Foundry. And this ID, we get it using the card generator you know, agent that we created before, and we get it instance, and then we stack the ID of that instance. This is a global variable that is created at the beginning of the execution of this, just to be able to start working with the generated uh, agent, the cards generator agent. So after we identify that agent, we tell the system to connect to that agent, and we will give a name to this tool. The tool will be named card generator. And something very important here is the description. This description, it does matter a lot to the system, because this is what allows the orchestrator agent, the one we are creating now, to identify what this tool is for and when to call it. So we need to be very descriptive and precise here. And in this case, I am telling the agent, this tool will generate creative business card data in JSON format with title, name, city, etc. And uh, it will do this according to the instructions given. So if we tell this to the orchestrator agent, whenever it needs to get a JSON for a card, it will call this agent, no? And it will send the natural prompt to that agent and get back the JSON. And that is where the second tool comes in action. This tool is an open API tool that would allow us to connect to the Azure function. And again, going back to our Azure portal, our AI Foundry portal, this is equivalent to come here to actions and add an open API tree specified tool. We give a name, a description, and next we define a specification of that tool. It is just a JSON that tell us what is that tool making, what it needs as parameters, what are the types of return. So we could do that everything manually or by code. Open API tool. You can see here that we can also have Azure functions as tools and could be wondering why don't use that if we are using an Azure function. And the thing is that this only work for a queue trigger Azure functions because in Azure we have many different kind of functions. There are functions that are triggered by HTTP, like the one that is filling the templates in our example. Other functions are triggered by message in a queue. Those are the only ones that work with this focus on Azure function in AI Foundry. And there are other that work like triggers when someone put a file in our Azure storage or maybe time trigger and each day they run automatically. None of those work here. The only one available to work with Azure functions here are the queue trigger functions. Because of that, I have chosen this kind of tool, Open API specification. And yeah, you just create a new Open API tool. Um, and what you see here is that I'm telling the system where is the specification for this tool, because if you compare these two tools, there is no spec here. We don't need a spec and a specification for this connected agent tool, because as the connected agent will be an agent inside AI Foundry, it is very easy for AI Foundry to detect the specification of that agent. We don't need to give it an additional specification. But when we talk about API tools, we do need to specify what is that tool about. So this is why inside the folder tools, I have a specification that uh, we are going to give to the agent to create its tool. And let me show that specification. Here is it. It's just a JSON as I told you before. And it has a parameter here, the URL of the Azure function. But other than that, it just has a summary. Then, and here we can see especially how we are defining what is going to be in the request body or the parameters that are required by our Azure function to work. And for example, we are telling here the system that it would require an object composed by these properties. Um, one of these properties is a name, a description. The other, I'm sorry, one of those properties is named the title. So this will be the title for the card. The name will be another parameter or another property of the object, the city, the profession, and so on. And here we specify what fields will be required. All of them are mandatory. And then we specify how will be the response of the tool or of the Azure function in this case. It will be an object of type string. And something that is very important here are the descriptions again. In the same way, the description of the tool for the agent will work because this will explain to the agent what it is expected to receive after calling the function, or in the case of the parameters, it explains what the parameters are about. So we need to be very clear and very detailed about what is each of these parameters that our function needs to receive. Um, and here you could be thinking that how you create this file, because there's a lot of structure and maybe you could make some errors while creating it. But there are many tools around that it could help you take the definition of an Azure function, for example, and generate this open API specification. Actually, our functions framework on Azure allow us to hit uh, an endpoint in our function application that will return this for us. And you could also use any LLM to create a valid open API spec uh, based on the specification of your tool. So this is not necessary to be created manually. There are tools to create the open API spec automatically, and then you could include that in your code, in your Python code in this case. So it could read that specification as we do in these two lines, and then have it in memory in this variable here, open API spec. And with these values in memory, you will be able to create your OpenAPI tool that will then be attached to your orchestrator agent, and it will be able to choose when to execute that tool that is attached to it. So now that we have defined these two tools, the connected agent tool and the OpenAPI tool, we could proceed to create the new agent if it doesn't exist. It has its own set of instructions, and it is very important to make a good prompting work here from your side. This is where prompt engineering is very required. So here we're telling the agent that it will receive requests for publishing personal cards. Uh, and these cards contain title, name, city, etc. And for this publishing, it is required that an HTML template be filled with the person's information in JSON format. So we are explaining here everything that the agent needs to do. And after this, The resulting HTML is published in a given URL. That URL will be the only response you give to your users. So everything is in this prompt. And just with this prompt and the tools that we are going to attach to the agent should be able to execute the work we want. It should, and actually it has the capabilities of extract the intention of what we need to do from the prompt and then decide by itself what of the tools that it has in its toolset should be used to complete the action and in which order, because it also is able to orchestrate uh, the chain of tools, for example, to complete the task we require. So with the instructions and the tools, we are ready to create the agents. As you can see here, we first combine the tools here, just like adding them up, and these all tools will be the ones that we attach to the creation of our agent. So our agent will have a model, its intelligence, will have a name and a description. Okay. Remember that this description is the one for humans. It is different to the instructions that are important for the system itself. If we get back to our Air Foundry and see our previously generated car generator, you can see here that we have this description of the agent. This is the description made for humans for us to understand what this agent does, and it is different than this structure. So these are not as important as this one for the system to work well. But yeah, for us, the developers or the people working with the agent, it will tell us what is this agent doing. So that is the main difference in these two fields, description and instructions. And then we have the tools. This will create the agent and we'll be able to work with it. And here again, just business as usual code for us to be able to call this logic from different applications. In this case, we have this agent web get tester. It is the application that will be using what we created before uh, to give us the business cards that we want to create. And this is just traditional Python code to create the function, to access the functions of the agent. And let's run it to see what it does. You can see here that I created this application to show us what is the AI Foundry project that it is using, what is the address of the function that is attached as the agent as a tool, and what model are we using here. Then I instructed the application to inform us what is the ID of the orchestrator agent that we are working with and how many tools it has available for us to work. So it is supposed that this new agent is now living in the AI Foundry. Let's check that out. Just a matter of refreshing this interface here. And yeah, here is the WebGen agent. And this agent has its own instructions, its description for humans, and you can see here in actions It has now the HTML template filler method that is in the function that we already deployed in the web. So we can see here what is the description that this tool has, and also the OpenAPI specification that I described for you before. So this is now part of the agent. And actually, this specification is the one that it uses to determine when to call this functionality. And it also has this connected agent, the card generator, this one. No? So this connected agent, it has a description that is very useful uh, for the main agent, the orchestrator agent, because it will have the knowledge required to determine when to activate this secondary agent. So this is why I have put in this description that this agent generates the JSON format that is required for the whole process. So in its smartness, when the orchestrator agent receives the initial prompt, it will determine that it is required a JSON first. So this is why it will start calling this agent and then calling this function. Now that we have seen how our agent was created, let's run, or let's ask for the creation of a business card. For example, uh, a veterinarian in Italy. Now you can see that this is taking way more time than the basic agent, because this needs to not only call other agent, but then call an Azure function, and that Azure function will download a file, modify it, and then upload a new file to the Azure storage. And after we um, execute this, the agent response is this, the URL card that was created. So we can go and see it from a browser. And yeah, here we have our business card. Uh, Remember that I just said the person was a veterinarian. Here, the agent decided that the person will be a woman called Julia, living in Florence. So everything worked as expected. The orchestrator agent was able to determine that it should call the connected agent to get the JSON, and then the JSON was passed to the Azure function, and then the business card was created. So with this, we have seen um, how to create the required resources in Azure to create a multi-agentic application, and also how to create agents within those resources, especially in our Azure AI Foundry, how to create those agents with code, how to create tools for those agents, and how to attach those tools to the orchestrator agent for it to decide how to execute the actions required to complete the action, the objective that we have. And you could use this to create any agentic application in this way. But as you saw, this is all open to the internet, so anyone could go and access our agents in our application, and that is where the knowledge in networking and security comes very handy to teach us how to convert this in a secure application. And this is why Nehali is here, because she has a lot of experience making these networking operations that will secure our applications. So with that, I let you, Nehali, to please explain us how is this architecture and what would be the next steps to convert this into a protected application.
Thank you, Walter. Excellent demo. Yeah, just
Yeah,
one. So we went into the details of this in the first video, but for the completeness of this session as well, let me walk you through um, on some of the flows. So we typically start with a hybrid cloud architecture, hub, on-prem, and a spoke. Okay, so let's first look at public networking real quick, the one that Walter just demoed, and I will hide the IPs for now. So this is the customer paths, and the biggest thing with public networking is that when we deploy AI Foundry, we have all of these flows are allowed from the public internet. So it's not secured yet. And then let's just quickly run through the flows. The developer would be accessing AI Foundry publicly, and then the flows between agent and search, and in Walter's case, agent and the function app was also public. We looked at um, between agent and search in the previous video, and then also agent and any third-party API will all be public. And for the completeness, we also had a connected agent, and in public setup, DNS is not so much of an issue because everything resolves to public IP. All our PaaS services like search, function, Foundry, all resolve to public IP. So, but DNS does become very important when we show you the private endpoints. So that completes the public, which the demo that Walter just did. Wanted to set the stage for private. So let me hide all of the public layers and then we can go into private. So in private scenario, what happens is, let me remove the customer's paths here. Okay. So in private scenario, what happens is we have a VNet injection that happens for the agent. So we have deployed um, a private endpoint subnet and a agent client subnet. And then we have, this is where Walter has a VM subnet. He'll be running his private endpoint demo from here. And then let's start with all the PaaS resources that are required for AI agent service. Again, this is also known as the standard mode, which requires all of these PaaS resources, storage, search, and Cosmos. And then the container app is injected into, the container app for the agent is injected into the client subnet. And so we also have the customer's PaaS services, the function app, and the storage. So the flows, the way the flows would work is we have a script, and Gabe will be going into details for this. Anytime you do private networking or the standard mode, you have to do it programmatically, and it will deploy all of the required PaaS services, the private endpoints, corresponding private DNS zones. We have 6 DNS zone. All of it we deploy programmatically, including, including this VNet injection and the subnet, these subnets. Okay, so we'll show you that a little bit later. Let's quickly walk through the flows. So the way the flows will work is, as you notice, no longer we can access any of the PaaS services publicly, and that's where the private endpoint comes into play. The Foundry uh, agent service private endpoints are already projected. Let's project. Um, let's talk quickly about accessing Foundry. We will no longer access it from public. We will access it from developers VM. Walter would be accessing it from this VM that's in the same VNet. So that's Foundry portal access, Foundry mock API. If you had one privately, that would flow like this. For Walter's app, we are going to project private endpoints, and this is really the meat of the discussion today. We will project all of these private endpoints for his, well, we don't have search, but we have function and we have storage. So we'll project those, and we will then have the way the flow will work is the agent will privately talk to the function app, and then there is one more integration because as you saw in the previous demo, the function app was storing content into storage. So how do we do that privately? The key concept there is that we will have VNet injection. So let me light up that. So we have a VNet injection. So we'll first VNet inject the function app, then the function app can privately talk to the storage. Now, the key point here is that there is when there is private endpoint, there is always DNS kind of special setup required for DNS. As you can see that all the PaaS services will resolve to private IPs. So for this to work correctly, these VNet links are important, and there is a, let's say you needed to access it from on-prem. There is a special configuration required for for the DNS to work correctly. I've done a deep dive video and the link will be in the description below. But be sure to make sure that your DNS is working and you peel the layer of DNS from the routing layer. Often we see escalations for that. So that's that. And then for completeness, we will have connected agents. Okay. So with that, anything, Gabe, you want to highlight on the private, on the architecture before we kind of look at all these resources in the portal?
Let's see. I think you covered most of it. I think we'll go over some of the limitations with the VNet injection portion of for the agent, given that we only support Class B and Class C subnets. That's something that will be covered there. But other than that, the architecture looks great. Thanks, Nahali.
Awesome. Okay. All right. So over to you, Walter, if you want to share your screen with the script that deploys all of these PaaS resources, private endpoints, DNS zones, subnets, and VNet injection. And then we will deploy Walter's app in it and make it secure.
Okay. So
Can you click one folder? Yeah, perfect.
yes.
Here, you should see the README with all the details on specific configurations that you need to use this. Okay. Under key information, you'll see that we have one for Class A is something you have to request. Okay.
Mm-hmm.
And the Class B and C are what is currently supported. Okay. So if you scroll further down, we will meet our prerequisites here. One, obviously you need to have sufficient permissions, but also there are a few RPs that we need to register before this can be executed, right? So please make sure these resource providers are registered. You can do this via the portal, or you can run the commands mentioned here um, to register. Otherwise, you will see failures in creating this the resources here, specifically the um, AI Foundry resource. As when we're doing the VNet injection, we require all of these additional RPs, specifically the Microsoft.app and Microsoft Container Service. Okay,
Oh, great.
so with these done, you should be able to run the template. If we go up to the main.bicep param file,
Where is it?
if you scroll further up, right here, there should
But
be the one below. So the main.bicep param.
all those are the parameters for the deployment.
Correct. So here is what we would be able to change to deploy. The top one location for it. Second one would be the name that you like to give the AI services, any specific model deployment that you're doing. So for example, this, I know Walter had a demo with GPT 3.5 Turbo. This case, template defaults to a GPT 4.0 to deploy the model. Okay. Um, Under the first project name, that would be the project that you are creating and the name you want to give it. So now, after that, on line 13, this is when the virtual network integration begins. There are a few ways you can do this, right? The template allows you to either bring your own existing virtual network, or it can create that for you, okay? How it works is on line 17, if you provide an existing VNet resource ID, it will take it and use it for um, all of the private endpoints and the VNet injection, okay? So let's say I pass a existing VNet here. We would then make sure the VNet name matches. We would pass the agent subnet, right, that exists in your VNet already. Okay, make
Mhm.
sure that this subnet is delegated to Microsoft that app slash environments. This is covered in the README as well. So if you follow the README, you should be able to um, have those details. So make sure that it is delegated, otherwise the deployment will also fail. Okay. And then if you scroll up, you should see the PE subnet name. So this is the subnet for all of your private endpoint creations. So the private endpoints for Foundry, Cosmos, Search, etc. will all go into this virtual network. Okay. If no existing VNet resource ID is provided, what happens is we will create a new virtual network with the name on line 18. We will then create the P subnet and the agent subnet for you already delegated so that the template can run with the creation of a new virtual network resource. Okay. One more thing, if you are passing an existing virtual network, what you can add as well, if you scroll further down, is here under existing DNS zones. If you pass the resource group, well, let's say you have one, the virtual network resource that already exists, right? And it is linked to other private DNS zones with the same name. So let's say you already have some AI services, some storage accounts that this virtual network leverages for DNS resolution. So what you can do is just add the resource group name here under each zone that you already have, and we will skip the creation of that private DNS zone for you, and we will use the private DNS zone you give, right, via the resource group. So we will look for a private link.services.ai.azure.com zone in that specific resource group you pass, And from there, it would use that as part of the group ID for the private endpoints. So that way, we'll still create the private endpoint for you, but the private DNS zone won't get created. Okay, so that's another configurability here. If you scroll further down here, these are the last parameters. This is if you do not have an existing VNet. These fields right here, you would have to fill out to ensure that it's essentially it's the VNet ranges, right? Um, so if you don't pass your own VNet, you need to provide the VNet uh, address ranges, right? Here is where you would have to add a Class B or Class C network range for each. Okay, so those are the configurations. I think for Walter's scenario, we created everything from scratch. So we didn't provide any um, existing virtual networks. We created all the networks, virtual networks from scratch, and we also didn't provide any existing search, Cosmos, and storage resources that will be used for your standard agent. Um, so all of those resources would get created under the same, under the resource group that you provide here. Okay.
Great.
Any questions or thoughts
Sounds
on
good.
this? Okay. So Nali has another environment that we will be using. Here she deployed it just like this via the deploy to Azure beforehand, as the script can take a little bit to deploy all the resources. So uh, if you go to this AI Foundry Private resource group, you should see all of these resources already created. Okay. Um, First things first, what we cannot do via the UI that needs to be done through the script is if you navigate to the AI Foundry here, you should see that under networking, the first two tabs, the firewall and virtual networks, as well as the private endpoints, all of these can be controlled uh, after creation. So if I need to add private endpoints to different virtual networks, or if I need to change my firewall to, instead of disabled, have selected networks with specific IP ranges added, or I need to add a service endpoint to from a different subnet that to allow access here, all of these changes can be done, right? But what the script handles is the network injection portion. As you can see here, the delegated subnet points to the agent subnet, and this cannot be done via the UI. So for us to use agents privately, we have to use a standard agent. The standard agent needs to be created programmatically, and the VNet injection that via the cap host also needs to be done programmatically. So this is what we are essentially creating for the agent to be VNet injected to this subnet that we passed, or in this case, created from scratch. Okay. If now you go back to the resource group, we should see several other resources created, including several private endpoints for each resource. We want to do a sanity check quickly, right? We just saw that the AI Foundry had public access disabled plus private endpoints. So let's go through the other resources here. If we go to Cosmos, and under settings and networking, you can see it is disabled as well, the public network access. And if we go to private access, we should be able to see a private endpoint right here, right? If we try to access anything here or in any of the other resources, it won't work unless we are in the same virtual network, right? So if we go back to the resource group, let's go to the next resource. If you scroll down, we need to go to search and storage. There they are. So if we go to search service, same thing, networking, disabled, private endpoint connections also. added here. Okay, and now if we go to storage account, we should see a similar pattern. Under networking, it is disabled. And then private endpoints, we have the P added here. So this should be good. If we try to access AI Foundry here, I believe this would fail since Nali is not accessing from the VM, right? Which
That's right. Yeah.
but we can validate that. So if we go to agents, you'll see, yeah, public network access is disabled. Okay.
Perfect. Should I jump onto the VM or did we cover all of our resources? Maybe DNS. We'll just show the DNS, so one of the DNS zone and the links just for completeness. We did a deep dive in the previous one, but maybe we just do. That's a link is important. Link to this one. And this is where my developer VM is. So I've already created a link to that one as well. All right. So should I jump onto the VM and just show that we can access? So we'll go to the resource group.
Absolutely. Let's do it.
And we'll just make sure we can launch it from here. And yeah, so I'm in a VM in Azure. Oops, sorry. I'm on a VM in Azure. And now if I go to this, am able to access it. We won't get that error anymore. Okay, so if you saw in my previous session, I do have 2 agents, but we will be creating Walter's, we'll be using Walter's app and create agents programmatically. In the first session, we did it manually. So Walter, are you ready? Before we jump on to VS Code, one of the things that I want to share here is that if we go back to the drawing board just for a second, the developer VM in my previous video was in a separate spoke, but for this particular demonstration, we are going to create a developer VM in the same VNet as where all of these private endpoints are deployed. That makes it a little bit easier for labbing purposes and for concepts as well. Okay, so here I will be jumping on to this VM and doing the rest of the demo. So remember, just to recap a few of the things that we've done so far. I know there's a lot of moving parts, so let me jump on the VM. So far what we did was, as Gabe mentioned, for standard agent and private networking, you have to do it programmatically we did it using this script, but you can use Bicep. Then that deploys all of these resources that we just went over. And then now we are ready to deploy the app that Walter has developed, but we will do it in private networking. Okay, so that's just to kind of recap. We've done a lot of different things. And then, of course, from DNS perspective, you don't really need to link this VNet because we're going to be in the same VNet agent test, agent VNet test. And so here I am. I'll just do a quick IP config here to get you guys oriented. This is the same VNet as the agent VNet. Okay. And I got this VM. I just want to share this awesome script that Walter has developed. It really created a nice, I ran this setup dev .ps1. It installed all the necessary tools, as you could see. And now I have a nice developer VM ready to go. And again, to recap, it's under the MISC folder right under here. Okay, so just took a few steps back to get everyone kind of on the same page where we are. And again, kind of from a drawing board perspective, let me share the VM subnet 192.168.2, and all of our private endpoints will show up in 192.168.1.0. Okay, so if I do a quick test over here, let's do a quick test here. We will NS look up the AI Foundry URL that's in here. It does indeed resolve to a private IP. In the, if you see the third octet, it's 1, and IAM, if you see the third octet, it's AMIN 2. Okay, so all good to go on this developer VM. We also tested, and I apologize for the duplication here, but we also tested that by the virtue of private DNS resolution, we were able to launch this AI Foundry from this VM. So if it fails, be sure that you are in a VM that is in the same sub VNet as where the AI Foundry private endpoints are. So going back to agents, this should all look clean. So this is a good starting point. Just wanted to do a sanity check there. Anything, Walter, before we kind of jump and git clone your repo?
No, everything is clear, Nihali. Thank you.
All right. So then let's go to VS Code, and we can kick off the git clone here. I have a brand new folder, and we will do this. Awesome. So here, Walter, you can walk me through.
Okay, so what we need to do first will be deploying the required services on your Azure subscription.
Mhm.
This
I'll
will be
keep the README open just in case. Is this the right README?
yeah, that is the general one.
Yeah,
I think that is up. If you want to go to the table of contents, and then it will
sure.
be
Yeah, let's
easier
do
for
it
us.
that way. Yeah, because I'm not very familiar. I know this has changed. I apologize. So
So
where
let's
did you?
go to solution setup, line 20. Yes, that one. And as you can see there, we have a in line 171, we have a reference to the infra folder, and there is where we can deploy all the necessary Azure components. So we can go there in the terminal. Yes,
Mhm. Is the font okay? Should I make it a little bit bigger?
it is okay, I think.
Okay. Okay, and in the terminal, agentic, webgen, and then
Let's get into infra. There you go. You have everything that we need to deploy the infrastructure. But first, let's set up the parameters that we will be using to ensure that we are, for example, using unique names for our resources. So please open the file parameters in your Visual Studio Code inside infra. Yes. that one. Especially, we need to change the name of the storage account, of the functional name, and also of the AI Foundry.
Okay, so we'll just do NN99 here. I think, actually, no, we'll keep the resource group the same. Sorry, the storage account.
Yes, you're right.
And then we also can do update all of these just in case. I don't have autosave on, so I have to remember to autosave here.
Okay, so I think we're ready.
Oh, let me make sure I also have the README. Okay, so what do we need to run next?
The exactly one you oh no, that is for your development environment. So let's go a little bit down. Uh, okay, it this part of this README is telling you to go to the README of the deployment of the infrastructure, and there basically instructs you that once you have ready your parameters JSON, you should execute the PowerShell script if you have PowerShell, or the Bash one in other case. So let's execute deploy infrastructure from your current PowerShell. Just type dep deploy, I'm sorry, and execute that.
So this is creating this resource group in Azure and deploying these resources, correct?
That's right.
Okay, perfect. Oops, I need to verify that I am. Let me just quickly do that. Okay, so we pause the video just to make sure I was logged in, and then let's run the deploy script again, Walter.
Yeah, nice.
Okay. All right, so we paused the video and we got this. I believe this is expected, Walter, right?
Yeah, since we are working in a corporate Azure subscription, it is subject of security policies that in this case don't allow us to make a container with public access. So this is why the script is failing. Nevertheless, this is something that will not affect us because indeed we are trying to make our application to run under a protected environment. So later you will be showing us how to be able to access uh, this container from a browser, but within a virtual network.
Exactly. So let's go quickly check just to be sure that it did indeed create the resource group. Okay, now it is here. So let's go into the resource group and verify that we have all the resources that you created. And to your point earlier, Walter, let's just go quickly look at the container. It should be there as private, right?
Yes,
And this is because of our corporate policy.
absolutely. And then we are going to need to upload our template for the cards
Mhm.
right there in the templates container. Um, so if you go to the main README,
Main README. Yeah. So there are two READMEs. This is the main one, and this is the one inside that infra
yeah,
folder. Okay,
it
got
talks
it.
about the infra. You could close it as we already
Done. Yeah.
found it. Yes,
Hmm.
and um, yeah, as we already have all the services deployed there, we just need to configure. Let's start with the storage and uploading the file I just told you.
Hmm.
So if you go down a little bit, or no, I'm sorry, it is up. It is above. Yeah,
Yes, this
yeah,
one.
there you go. That is the command that you will be using to upload the file to the storage.
Sure. So let me just make sure I grab the right storage account because we changed the name. So I'll just grab, oops, I'll grab the storage account and then, so we put my storage account in here. Oops. And then we want to be in that folder where we could access miscellaneous as well, right? So we have to run it from right here. So let me run this one.
Mhm.
Not sure if I have all my shortcuts here, so let's see if I can just control enter this command. No, I cannot.
Yeah,
Yeah,
that is because it is something that Visual Studio Code has, but you have to activate it
yes,
each time.
no worries. I could just copy and I'll just paste it here. Okay, great. So we got that one. So the template is indeed now in the
Uploaded.
container.
Yeah. If you want, you could check that out. Get inside templates. There you go. It is there.
Perfect.
Cool. So now we have our storage ready. We could grab the connection string. So our Azure function, um, well, actually, this is something that it is done automatically by the script. So let's just get into the Azure function, please, and see if the environment variable is there. Please go to settings and environment. Yeah. So please show the value of the Azure storage connection string.
Yeah, it has the 99. Yeah,
Yeah, it
perfect.
is it is there. So the next step will be uploading or deploying the actual function to this function app. And for that, we could use the command line
Sure.
and function tools.
Yeah, so um, Walter, just real two quick comments I wanted to make about the resource group and the infra that we just deployed is that the storage account is still just kind of a before and after picture. The storage account is still public, enabled from all networks, and then function app is also public. Yeah, enabled with no restrictions and no private endpoints, right? So at the end of this exercise, we will have everything private, and I just, for completeness, I should hit the private endpoint tab as well. So there's no private endpoint. And then the other observation is that this AI Foundry that we deployed, we will not be using it. We will be using the AI Foundry that's in the private resource group.
Mm-hmm.
And okay, so all right, so this is okay. So I'm back here, and okay. So what should we do next here?
Um, let's deploy the function. Get inside the folder of the function, please. It will be agentic WebGen.
Um, all right, so it would be under this
That's
one,
one.
the tools functions. Okay, and should I also be in that in the PowerShell as well?
Mhm.
Here we will use the AZ tools to publish the function. Is that how we want to do this?
Yeah,
Okay,
will
perfect.
work.
So then let me grab we need this name, right? And just for completeness, there is no function deployed here, so that at the end of this exercise, we will have that, right?
Yes.
Okay. Oops. So looks like we didn't have the function core tools installed. So we paused the video, we installed it, and Walter has diligently updated the setup dev as well. So as of this recording, we did it manually, but you may not have to do it manually. So Walter, we may have to set up the environment variable, but let's give it a go to see if it fails. If so, we will have to launch Visual Studio Code again. Yeah, so it's not recognized, so we can restart Visual Studio Code, right?
Yeah, that would do the job.
All right, so let's start Visual Studio Code again. Let me just verify that function does exist, and then let's launch code. And hopefully I still have my command handy. And we can go to agentic, and then we can go to this one, right? This is where we would run it from. So let me grab the command. Hopefully we still have func. We can vary. Okay, here we have it, and we'll do publish, and we'll grab the function URL from here. I mean the function name from here.
Mhm.
Looks promising or not. Oh, we had to do the dot. We have
Yeah,
to
that
do
net
this.
isolated.
Yes. All right. Let's try that again. All right. So Walter, looks like it's done. So we pause the video just to make sure it's finished, and looks like Walter, it's done.
Okay, so now that we have our Azure function up and running, um, we need to grab the URL that was generated for it,
Mm-hmm.
exactly that one, and update our .m file with this address because it is important for the agent to know where to look for its function. So let's go to the uh, Agentic Webmaster folder in the top. And yeah, let's set up our environment variables with this
Okay, so
value.
I can just change this to env, right?
Yeah,
Okay, and then the function would go right here, the one that we just got. Is this the one?
um,
Or do we
Azure function URLs. Yeah, but we need to,
grab it from the function, right?
yeah, in order to get the security code to access the
Yes.
function.
Yeah. So let's refresh this, and we should have our function here that just got deployed. And we'll grab the function URL from here. Oh, copy, and we'll paste it here. Okay. And then let's make sure that I do have GPT 3.5, and then we need to get the project endpoint from Foundry as well, right?
Yeah, that's right.
Mm. So go to the portal, and we go to overview. Let me grab the Foundry endpoint, and while we are here, I'll just double check. Okay, so we do have Turbo, and let me put this back in here. And remember, this is the private one. Okay, so not to use the one that got deployed with the script, but use the private one.
Yeah, that's the idea.
Mhm.
So
And then we have this, and we just need to grab the storage connection string. So going back, we'll try to navigate it from the resource group. That way we get the right. We did have the resource group open somewhere, and we'll get the right storage account, and we'll get the connection string. Okay, that looks just about right. Do we want to call this environment private, or does it matter?
um, we could call it private. Yeah, that's right. This is just in the
Yeah.
case that we want to have the different configurations in the same file.
Yep.
That will not be a problem.
Let me save this. I don't
Um,
have autosave enabled yet. So now the environment is the .env is ready.
mhm. I think now we can start testing our agents to see if they are able to access our AI Foundry as the one that is deployed with the script from GitHub. It is configured to not be accessible from the internet, just from the VNet, right?
Hmm. The
And
AI Foundry, yes.
yeah, and since this virtual machine in which you are working in is within that VNet, it should be able to work with that AI Foundry. So let's test that.
Is this the one? Is this the tester?
Yeah, please open it in the editor. Yeah, and hit the execution button.
Okay. Yeah, and this is the
Yes, we could allow that.
yeah, and this is the key, right, Walter? This is where a lot of the kind of networking pieces, kind of stitching it all together, is that if we have to be on this VM because at this point AI Foundry is already private.
Mm-hmm.
So if it fails, that means you're not in a private network. So I just did a run and
Oh, we need
oh
to set
yeah,
up the
act
packages, the requirements. I'm sorry
yeah,
for that.
sure, no problem. So
Let's go to um, agentic dash webgen. Exactly. And no, not that one. Agent webmaster without the S.
oh yeah, I still haven't memorized all your paths yet.
Yeah, no, understandable. So if you want, you could create an environment just to not miss.
All right.
Okay.
So Python dash m v dot ven. This should work, or is that
Yeah,
something?
that is
Okay.
great. Yeah,
Okay.
and then we could activate it. And
Uh, Linux, you have to source it. Okay, got it.
yeah,
So now I got it. Perfect.
we are there. And now pip install dash r requirements.txt.
Okay, awesome. So I'm glad you have this tester because this is just validates the connection to a private AI Foundry.
Yeah, we could
Yeah.
start simple with it.
Yes. Agree.
While packages are installed.
Should I give it a go?
Yeah, please. It hasn't been updated. We should restart Visual Studio Code or just type Python and or just get into the folder of the car generator. So please do cd car generator. Oh, cd agents and then car generator. AG, yeah, that
Mm-hmm.
one,
Mm-hmm.
and Python.
Oh, you're saying just
car
run
gener-
it from here.
Yeah.
Okay. All right. So let's run this. Okay. We see an error. Walter, we've seen this error before.
Yes.
And this is the principal ID of the VM that we are running it from, right?
Yes. After a very deep research that we did by ourselves, we detected that uh, that ID belongs to the VM in which we are running this. This is a VM with access to the private network that we set up for our demo. And the virtual machine itself is trying to communicate with the agents to execute the code that we created in Python. No? So it is very important that this virtual machine is authorized in the AI Foundry so it could operate with our agents and our models without any problem.
Right. So let's add that permission then. So I went into enterprise application, and when I punched in the principal object ID, it found this one. Okay, so and that belongs to the VM. So let's go ahead and go to our AI Foundry resource and add the permission, the role assignment. And the role we wanted to give was cognitive services user. And we go to select members. We punch in that ID. It belongs to dev VM. Select next, review assign. This does take a few minutes, so we can go back and check whether it did it. Cognitive services. So this is the permission in question.
Mm-hmm.
Let's go back and try it again. We may have to pause, but let's see. Okay, so now it is asking for prompt, and we could say card for a cloud architect. Is this a good prompt?
Yeah, it will auto-generate the rest. Or as you can see there, the application is made that in a way that you could just press enter and it will make up everything.
Woohoo, looks like this worked, Walter. So it
Auto-generated.
is, yeah. So this hasn't created the tester does not create the agent yet, right? That's just making sure
No, the
that we
tester
are
is just
talking.
created.
Oh, it did create the agent. Okay, so
Yeah,
it
because
does.
an agent is required to convert your prompt into that JSON.
Okay,
Mm-hmm.
I see. I thought the tester was only just making sure that we can talk to the um,
Well,
AI.
the structure is as follows. We have two agents, and each agent has its own tester
Got it.
because the agent itself is not an application, just the agent with its knowledge and the things that it knows how to do. But to test the agent, we need another application, and that is why we have those other tester Python files. Those represent applications using those agents.
Got it.
Mhm.
Yeah, so the next step here is
And now that we have tested this uh, basic agent generating the JSON and so on, we could go ahead and test the whole application. Uh, that is the tester for the AG card generator. So yeah, I'm sorry, the tester for the AG WebGen. It is the orchestrator agent. So you could go to the next folder, Nehali, the AG WebGen.
okay.
Please.
So the AG underscore webgen, this one. Okay.
And you see, there is the AG WebGen Pi. It is the agent code, and then a tester for that
Mm-hmm.
code. So if we run the tester, we will have an interactive application that will receive the prompt and then send uh, this prompt to the first agent, the basic one. It will give us a JSON, and then the orchestrator will take this JSON and send it to the function, and there we'll have our card exposed in the blob storage.
Right. So right now everything's public, so we expect this to work.
Yes.
Well, the function is public. The services is
The Foundry is already protected.
yes.
So
Foundry is private, but the function is still. So I could just say, hit enter and, or I
yeah,
can say it will pick a random card.
absolutely.
Should make sure our storage account hasn't changed, right?
Yeah, because it could have changed because our policies.
Yes. So WebGen. So we open storage account and we open, let's open the function as well while we're here. So the storage account networking, yeah, we need to ensure that it's disabled. Our policies have disabled it. And so that we don't have private endpoint. And let's look at the function. Function should be public. Yeah, so function is still public. On the storage, do we want to review any other permissions? Um, do we need these two?
Um, the key access it is required because the function is trying to access the storage account through its key access. And the well, the anonymous access it is something that is also required for the container to the container that has the generated cards to be able to expose the the cards to the browser, for example, no, without authentication.
Yeah,
But
and we'll make it secure after with
yeah,
private now. Yeah.
but if you hit refresh, please, we have a policy that uh, doesn't allow us to
Mm-hmm.
have this enabled permanently. So we could experiment what happened. Well,
Mm-hmm.
the card will be generated, but maybe we won't be able to see it in a browser. So
Sure.
let's try that to see what happens.
So here it failed because I think that was because of our storage account.
Yes.
Okay, so okay. So after the storage, we need to restart the function.
Yeah.
So let's do that.
Start.
And then let's go back and try it again. And there is a way to test this function manually as well, right? Should we also try to do that while we're waiting here?
Yeah, it is recommendable. So we are sure that the function is working before we test it from the agent itself.
Yeah, looks like it did
Oh,
work.
well, now we don't need to do that direct test because this worked. But I'm
Perfect.
curious
But
to see if
maybe just, yeah, for the benefit of our viewers, you could just paste it here.
not there in test run, please.
Yeah, in test run. We could just
And you could
paste it
paste.
here
Yeah.
and run. So,
Well, this is an interesting error here. It is complaining about we not have enabled the course. Um, so we could call the function from a browser. So we need to do that. It is very easy, just clicking the link of course. Ali, please.
Configure course, this one or okay.
Yeah, the next word course in the first paragraph.
Okay.
Yeah, that one. And you just type in allowed origins a star. Yes, that and save it, please. This will allow us to call our function from any browser. But it is just for testing purposes because in production we only should be approving the right domains we want to be able to call our functions through a browser.
Right.
This takes like a couple of minutes to propagate.
Sure. Okay, so we can come back and revisit that.
Yeah,
But it did run over here. We can see that we got the URL.
yeah. Now I'm curious about uh, watching if we are able to see this blob from a browser. Yeah, no.
Yeah, we expect that to fail because of our access policies.
Yes.
But if we go in here,
Card.
cards, is that the template? 446, this one?
Yeah, that is the one. Yes, it
Yep.
contains the even the last second when it was created.
Yeah. Okay. So that it's there. It's our corporate policy that's not allowing us.
Mhm.
Okay. Now let's do a quick test here.
Yeah, now it run.
Yeah.
The course permission is already propagated. So this is a very nice way to test our functions when we don't need like a REST client from our side. We could use this browser-based test.
Awesome. So now we have our first agent, which was this one, and then our second agent as
Yeah,
well.
that was the complex one. If you can see in the right pane, it has the tools, connected agents, things like that.
And this one is connected to the card generator.
Yeah, absolutely. You're right.
Awesome. So is there and then I think just to call out, Gabe mentioned this in the first video, but when you see this, this is a clear giveaway that it is deployed in a secured network, a standard agent deployment. So, Walter, we are ready to do this now privately. So let's set up our function to be with private endpoint. The app is working as expected, right? With public, or is there any other validation you want to do?
Yes, I would like to make this one we did when we were preparing this and
Mm-hmm.
was trying to access the AI Foundry from the internet. I mean, not from this virtual machine that is inside the VNet,
Mm-hmm.
but for example, from your desktop machine,
Yeah.
access your subscription. And it was surprising for me that as the AI Foundry is configured private, uh, I wasn't able to access it from a regular desktop machine because it is not in the VNet and doesn't have the permissions to access it. So it will be great watching this before we move on, if it is possible.
Sure, absolutely, Walter. So let me bring my other screen where I have it deployed. So I will log in from, so to speak, outside, right? So not from the developer VM, but from the, okay, so here we are in that resource group, and this the private resource group, and this is the AI Foundry in question. So you want me to launch the portal and see it fail, right?
Yeah, basically.
Okay. There are
But this
times when
is,
we,
yeah, there you go.
there you go. Yeah, and just to kind of do this visually, right, like we did it in, so what happens is that all of the, given all of the private endpoints are projected, uh, the inbound to any of the PaaS services would be restricted. So the developer would access it using the AI Foundry. You can only access privately.
Yes.
Nothing from, so the red means outside, green is internal user. And so we just access it from this VM, it works. Is that good, Walter? Should we move to back to our VM?
Yeah, let's make this even more private by turning our Azure function available only for the VNet.
Yes. So let me now go back to my, let me close this. Okay, let me go back to the VM. So here we are in the VM. Is there anything else to test, or should we convert it to private now, the function?
Yeah, we could go ahead and convert the function to private because the application was already tested. It is working with a private AI Foundry. Now let's see what happens with a private function.
Yeah, so important thing to call out is like we just saw, AI Foundry is resolving to private, but if I resolve the function, and this is a good sanity check, Walter, to do before and after. So if I go to the function, so let's go to the function. So I'm trying to find where my function is. Yeah, there. And we get the function FQDN. Right now it will resolve to public. So we can do an before and after. Okay. So
Mhm.
if I do this, you could see it resolves to a public IP. Um, after
How,
we
how,
switch it,
how do you know that it is a public IP for us developers to know this?
great question. So as you know, our VNet is 192.168.1. And if you, let me show you just one glimpse of RFC 1918. So bear with me here. So in networking, and I got this from the Cisco website.
Mm-hmm.
There is a concept of this RFC 1918 that you see at the bottom.
Mm-hmm.
So anytime you are doing networks within Azure, we call them private networks, you will see that they come out of either the 10 space, 172.16 space, or 192.168. Okay. And our space, if you look at our space, it is 192.168. Okay, so anytime I see things in 192.168, it's referred to as RFC 1918, and it's referred to as private. Okay, so it's not
Mm-hmm.
publicly routable without getting either a VPN or some sort of, if you're on the VM in Azure, you can get to it, but it's considered private space. So anytime I see these IPs, my eyes know it's private. And um, if you remember, Walter, Gabe even talked about class A, B, and C. He
Yes.
mentioned that in Foundry, class A is in agent, standard agent, A is not supported. So you cannot use the 10 dot IPs. So we're going to be we did use this one, 192.168. And we sliced it we sliced it as a /16, so we get lots of IPs there. Okay.
Mm-hmm.
Um, and here, if you see, so these are the other classes which are public, that there is multicast and other things. But when you see 20, so kind of going back here, if you see anything in the 20 range, 20.119, that falls in this category. So 1 through 20, this is the first octet. See, it says first octet. So if you saw something in the 20 range, that is a public IP. So
Okay.
easiest way to remember is that, we've picked a class C in our deployment, but I made it a /16 so that we can get nice little boundaries, a /24 boundaries. But technically 192.168 is a class C. Okay.
So whenever we see uh, an IP starting with this 172 or 192,
Yes.
uh,
Or 10 dot. Yep.
they are going to be private, right?
Mm-hmm.
Cool. Awesome. Thank you, Nelly.
Yep. Good question. So yeah, so let's go back, and that's why I think it's good to do a before and an after so you can see what is going on. Okay.
Mm-hmm.
So we'll leave this here. Let's go to our function. Let's go to our networking. And here it first what we will do is we'll disable public access. Okay, so that's your first step. And then we will enable private endpoint. Okay. And then we go see it says private endpoint not configured. So we'll say private endpoint, add advanced. And we'll call it, let's give it the same, oops. Uh, we'll just call this NN99FX PEP. I like to put PEP at the end just to show private endpoint. And this will automatically pick the resource and the target resource. This is the important screen. So what we want to do is we want to put this private endpoint in that agent subnet, if you remember, sorry, agent VNet. And within the agent VNet, we have created this PE subnet. Remember that script already deployed this PE subnet. So we're going to put it there. Okay.
So whenever we create a private endpoint, it should be assigned to a subnet specifically, right?
Absolutely. And just to kind of give you a visual, it has to be in the subnet. Oh, let me just see.
And this action is what is normally called the VNet injection.
Not yet. So good question.
Okay.
So this action is just that what we're doing here is, let me hide some of this. What we're doing here is we have all of these customers PaaS services, right? Is we're projecting this function into this private endpoint subnet. So far, we are only kind of giving it an IP in this subnet. Okay,
This is like the projection phase until now.
say that again.
This this is just like the projection phase.
Yes, just the
Also,
projection. The time that we would need VNet integration is when you want this storage function to talk to this storage. So that we will do next.
okay, got it.
Okay, so far we will only do this part and the NS lookup should start working because we will be linking we will be linking this private DNS zone to this VNet. Okay.
Mm-hmm.
So here we are. So far we have only done the virtual network part. We are in the PE subnet, and then we go to DNS. And this also is important. So we are creating Azure Websites.net, and let's it's an existing one. So best is to, let me just make sure. Sometimes if it's an existing one, it would not link it automatically. So let's just make sure.
And that DNS zone, was it created with the script that we executed from GitHub, or is it one that is already on Azure somehow?
Yeah, that's a great question. This is where often it does get a little confusing. I'm glad you asked. So let's take some time to Azure websites, right?
Yeah, because it has some name, like a very official name. It looks like if it was
Yeah,
provided by our platform.
yes. So in my case, because I had other um, functions deployed, it does have it already created, but I think best is to remove this so that you can actually see. Um, it will, if you didn't already have it, it will actually create a new one. So if
Oh,
you want, we could, because this is, I think if you want, we should probably delete it so that you get the brand new experience.
okay.
Um, so let's do that. So if we, so I'll just delete both Azure websites .net. Okay, so pause the video. It deleted the two private DNS zone. So let's start it again so you get to see the full experience. So we'll do advanced. We'll call this NN99FX PEP. I call it appended with the private endpoint. And let's pick the target resource. And this is the important point. Like I mentioned before, we want to put it in the private endpoint subnet. And let's look at the DNS part now. So notice how it says new. Okay. So because this is new,
Okay.
this is the first time, this is where a lot of times I see customers missing this point, is that it will automatically link this VNet. But let's say you had an existing one, like how we had it before, it will not automatically link. So you have to manually link it. Okay, so pay
Okay.
attention to this new versus existing. Okay, so the new one would work just right. If you have an existing one, don't forget to create that link, and I'll also show you visually while it deploys what we just did. So this is the link, Walter, that I did to the this Azure Websites.net private DNS zone. So this link is very important. Um, and I'll show you in the portal as well what that looks like after it's created. So we can try to refresh it here to see the Azure Website.net is created, not yet. So we'll just wait for this to finish. So our private endpoint deployment is completed. And now if we look at our Azure Websites.net, you'll see that we have a record set of 13 for our function. And we also have a virtual link to the agent VNet. So it's good to validate that this indeed works. And let's now go to the function. Actually, we'll just go to the actual function app. This one. we'll do the NS lookup again for this. So we'll grab this. Okay, in fact, we already have it. So let's look up NS. Let's do NS lookup. And here's a trick question. What do we expect the IP to be? Exactly what we see in the record sets. So I expect the IP to be 1.13 over here. Okay,
Right.
so there we go. There is 1.13. So our DNS is working correctly. We are indeed going to private. So the function is now private. Now, because your function is talking to storage, let's make the storage private first, and then I'll show you the VNet integration. Okay.
Yeah, let's do that, please.
Okay, so with the storage, let's do a before and after for storage as well. So, so let's open storage in a new link. And NSLOOKUP is a great kind of command to have in the toolbox to do any kind of troubleshooting, right? So we'll look at, I believe the best way for me to get this is through endpoints. We'll just get like this endpoint. And we'll do a before and an after. Okay, so this would resolve to public. The 20 IP is public, and after it should resolve to private. Now we'll do that same exercise, Walter, because I may already have a blob.
Mhm.
Let's see. Yeah, I do already have it in here. So you will notice that if there is an existing one, it will not link. Okay,
Mhm.
so it's important that if you want, I think we could delete this particular one. Let me delete the links. It does require you to delete the links before you could delete the private DNS zones. Because I do have one already in this RG from my previous demo, so we'll delete that. Okay, so now we should be able to delete the private DNS zone now that I deleted the links. So we'll delete the one in this resource group. Okay, it's deleted. Does take a few seconds to go away from here, but let's start our private endpoint for the storage. So first thing we will do is we will disable public access. Okay, so
Mhm.
that's the first step. And then we will, so it's done, and we'll go to add the private endpoint. So with private endpoint, the same thing, we'll call it NN99 storage PEP, and the same, we will project it in the same. So we pick the blob as a target resource, and we'll project it in the same agent VNet and PE subnet. Now DNS, notice that this is new, so it will automatically link to this VNet. But if your customer doesn't if has an existing one, just be sure to link it manually. And I'll show you how to link it manually. Just remind me after this.
Okay.
All right, so we're ready to do this storage private endpoint.
Yeah.
This has been a marathon, Walter, almost there. Okay, Walter, looks like our deployment is complete of the private endpoint. And let's go ahead and look at our private DNS zones again. And in here, we should now see the link. Okay, so this is the first validation. The second validation is the record set. Notice we got 1.14. So now if we resolve the storage, you will see 1.14. Okay,
Yes. Yes.
perfect. So we have 1.13 for the, I am saying 1.13 as I'm reading the last octet, but it's 192.168, 1.13 and 192.168, 1.14. So now if we run our app again, I expect it to fail still because we have, but let's run it so that we know. All right. So is it okay if I go ahead and run?
Yeah. Let's do it.
Okay. Okay. I expect it to fail because we haven't done the VNet injection. So let's see what message we get. Let's record that error and then we'll fix it.
Mm-hmm.
Okay. So what has happened now, and going back to the drawing board, I know this was very important for you, Walter. So I'm kind of doing this again. Um, what just happened is we have a storage account and the function app both private. So there is no inbound, right? No inbound. So then how does the function app talk to the storage account? For that, the concept of VNet injection comes into play. So let me add the VNet injection here. So this is what we will do, VNet injection. Let me hide all the IPs. So we will do VNet injection, and after that, the function will be able to talk to the storage using this green flow
Okay.
because there is no public access. Okay,
Mm-hmm.
so this is the last part of the setup. So let's go back into the portal, and the where you do the integration is you go to the function app, you go to networking, and see this is outbound, right? So if you think about it, it's going outbound from function to storage. Private endpoint is inbound into the function app. Okay, so let's go ahead and do VNet integration. This is not configured. And we'll say add virtual network. And we will inject it in the same private. We will just we'll create a separate, let's do this for a cleaner implementation. We should create a separate subnet. So let me pause here for a second. Let's go back to the drawing board. I want to show you one more thing, Walter.
Mm-hmm.
We'll create this extra subnet where we will inject this. Okay. Uh, you can do it in the existing one, but it's better to create a new one. So let's go back and let's open a new tab here, and we'll call this virtual networks agent test subnets. We'll just create an extra subnet for function app here. And it picks the next available network. The last octet is .3. I mean, the third octet is dot 3. Okay, so we have this. So now let's go back to our function. So we'll navigate it from the resource group, networking, VNet integration, and we'll put it in the new subnet that we created. That way it matches our diagram. And you can see that it will not let you put it if it's a private endpoint subnet, it will be grayed out. So, all right, so we'll say connect, and now we're officially, once we are VNet integrated, function and storage should be able to talk to each other.
Okay.
And while we are waiting, remember I mentioned about if the for whatever reason there is no link to your VNet to the private DNS zone. So I'm in the private DNS zone. You can manually add it. Okay. So this does happen in the real world where customer may have an existing private DNS zone, and if your agent VNet link is missing, you can hit add over here and then add that link over here. Okay. All right. So going back to the VNet integration in the function, and you can see that we are now, if you go back one level, oops, I went too far down. We can go to networking, and this page will tell you that we are VNet integrated, and you can see the VNet integration over here. Okay, and you can also see the private endpoint here, public access disabled, everything, all the sanity checks over here, no public access, private endpoint, and VNet integration. So let's give it a go. This is the moment of truth, Walter.
Mm-hmm.
After our 3 hours, 3 something hours of recording. So I'll just hit default.
Mm-hmm.
Woohoo!
There you go.
There we go. All private now with private endpoints. So let's grab this one. In fact, we know that because of our corporate policies, we wouldn't be able to see it, but let's go in the browse through the portal. So it's 4019. And so we go into the portal and we go to cards. We can refresh this 4019. It just got created. And if we can download this to see the HTML because we are not able to open it. And there's our card.
Awesome. You did it.
We did it. So again, a function app, public access disabled, and on the storage account, let's go on the storage account one more time, and
This is great
public
because
access
nowadays
disabled. Mm-hmm,
most of the applications that involve AI,
mm-hmm.
they manage a lot of private data from customers, from the organization. So the enterprise is interested in generate this kind of applications. Most of the time, they will like to have everything very well protected. So this is a very good sample on how we could achieve this kind of protection of our AI based application. So that is why getting these results is very good for us during this demo.
Excellent. Yeah, absolutely, Walter. It was a pleasure collaborating with you. And as one last thought over here, so we could get this part of the recording, is that let's go to the virtual network one more time. I wanted to show you what happens and how you can, if this delegation is missing. Um, so for example, when we created the agent subnet, it was delegated to Microsoft.app environment. And when we created the function avenue, and anytime you do VNet injection, VNet integration, it does create a delegation.
Okay.
So both our agent and function app are VNet integrated. So you could see that's why in the diagram I have two blue lines. And when we do that, it also creates the, you'll see that in this column under subnets, you will see those environments delegated. So if something is not working, you can come here, double check that these are set up, indeed set up correctly. Because Gabe mentioned this, that our script does it, but if someone does it some other way, and if they're missing it, then this could be a problem. Okay.
Okay. And what is exactly this delegated concept about, Natalie?
Yeah, so good question. So let's go into the function app. And if you see over here, you can see that this subnet is now delegated to the app environment. So anytime you can either create it manually, you can click the drop down here and add it, or anytime you create this VNet integration or VNet injection, it will automatically do it for you.
Okay,
Okay,
got it.
awesome. So anything else before we wrap this?
No, I think now it is clear for me. Thank you, Natalie.
Awesome. So thank you, Walter, again for also helping me have this dream developer VM where I could do a lot of the development, and I'm totally empowered now to run your code and look through it. So I appreciate everything and working with you.
Excellent. Thank you, Nehali, again for sharing your expertise in these matters that normally are not so reachable for us as developers. And yeah, with this, I think we have more tools to decide how to design and build our applications without being afraid for the moment in which these applications need to be private. So thanks a lot again for that.
Absolutely. And thank you, Walter. Thank you, Gabe. And thanks again, everyone, for joining. And we will see you in the next video.
Thank you.